Want to take a second to welcome all of you to the University of Houston. Want to extend a special welcome to my colleagues from the University of Utah for being a part of this conversation here, for helping us organize this and put this together. Sorry for the technical challenges. We'll try and get back on time as quickly as we can, understanding that both Bill and I have 4 minutes to introduce this topic and welcome all of you, and also to thank a whole bunch of people for making this happen. First of all, just in the interest of safety, there are no fire drills planned. If you hear a fire alarm, if you hear a notification, it is real. We'll get out from here through multiple exits. The one that you came through, that's one way to get out. And then there are a series of exits on the right-hand side as well as on the left-hand side where you can get out of the building, and the muster point is out in the front of the hotel. So get that out of the way and make sure everybody is sure that if there is an emergency, it is real, and please do make sure that you get out in time and out of the building. So this is our first effort to put together a conference with a powerhouse from the University of Utah. They've been doing some fantastic work in the area of energy, along with the University of Houston, which is in the world's capital for energy and is also a significant powerhouse in energy. I'm going to try and walk you through some of this very, very quickly from the University of Houston side. So welcome. This is me. What we do really as a focused effort to build our efforts in energy is to educate, innovate, and build partnerships. And for that reason, the University of Houston has actually trademarked itself to be the energy university, something that nobody else did. So we grabbed that opportunity and took it on and said, being in the capital of energy, let's be the energy university. And so that's been a big focal point. The fonts are messed up. Just I'll tell you very quickly, we are a Tier 1 university. It's a flagship university of 4 university systems. We educate 48,000 students on an annual basis on this campus, and about 75,000 students across the system of universities here. More than half of our students end up staying back in the Houston area. One of the remarkable things is we are perhaps the most diverse, or the second most diverse research universities in the country. We trade spots 1 and 2 with Rutgers University. This year we are number 2. Previous years we were number 1. So we do have a lot of different programs and research centers, but just to highlight for you in terms of some metrics, we do $240 million in research, and we are ranked 70th amongst all public universities by US News and World Report. I was going to try and play this video. I hope it can play. If it does, this is all I need to say. You can't hear the audio, so it's perhaps going to be lost on you, but this is the story about superconductivity. It is a flagship at the university in terms of research efforts. High temperature superconductivity has been an idea that's been around for about 40 years. It was first discovered at the University of Houston and has since been developed, where it's gone from the realm of science fiction to actually transforming energy. So superconductors are going to be the critical material to actually make fusion happen. It's also being used for transportation, levitated mag rails, as well as transportation from automobiles. So I'm not going to belabor the point here. I'm going to skip over and just thank a very important group that has helped us direct the efforts that we do at the university. And that's the Energy Advisory Board that we have. These are all C-level folks from the Energy Advisory Board. A couple of the members of that advisory board are in the audience here today. And a big thanks to them to really help shape the conversations that we have at the university to drive the research efforts. Our efforts are focused on traditional oil and gas, on the energy transition area, on areas of downstream chemicals, as well as an energy education. I'm going to very quickly jump over all of this just because in the interest of time, and just tell you that I'm Ramanan Krishnamoorti. I'll be in the audience, happy to answer any questions that you might have, and it's a true delight to have the University of Utah here come and partner with us in this effort. And my co-conspirator is Milind Dio. Milind is an alumnus of the University of Houston. He got his PhD from the University of Houston as a chemical engineer, but he's gone on to achieve really great things at the University of Utah. I'm going to let him come and tell you a little bit about what he oversees there. So, Milind?
Thank you very much, Ramanan. We appreciate the warm welcome and are delighted to organize this joint meeting with the University of Houston. Okay, that's me. So I'm going to give you a quick overview of Energy and Geoscience Institute, which is basically an institute within the University of Utah. It has about a 50-year history, and we are part of a university that does about around $700 million in research. So we are also an R1 university with a large medical school and a fairly large business school, law school and all that. So the entire professional program. So EGI was formed in 1972 as basically two institutes. One was the frontier oil and gas exploration, and the other was geothermal, and these two merged in 1990 timeframe to create basically what is EGI. And currently we are organized into several of those sectors, and you will hear from researchers in each of those sectors: the conventional oil and gas, renewables and geothermal, grid resiliency, and decarbonization aspects. So I just wanted to show this one slide to highlight what's happening in the energy space right now. You basically see the energy mix in 2013 and energy mix now in 2023. Actually, when I made this chart, even as an energy professional, I was quite surprised to see that the proportion of oil and gas that the energy mix, that was part of the energy mix in 2013 actually increased from 62% to 68%. Coal, of course, went down, but natural gas made up for that and more. And it basically shows the challenge that we have in getting to what people are considering net zero by whatever metric you use and by whatever time period you look at, 2030 or 2050. Anyway, so the EIA chart there shows how the projections on carbon emissions over the next 30 years or so. So we need to really be, I think, on our game as we look at the different aspects of energy and how we can move the low carbon technologies forward, while of course providing sufficient energy for the world. And as part of that, we of course do conventional oil and gas. We do have some large databases that both onshore and offshore, and are looking at worldwide exploration and some shale research. We manage the Frontier Observatory for research in geothermal energy, and researchers from that are here forged. And as you probably have seen in the news, it has had some significant breakthroughs that are actually being used by commercial companies. There have been big advances in drilling, induced seismicity monitoring, as well as stimulation in dry hot rock, that those advances that are being created in Forge. We also manage several large carbon safe type demonstration projects, from what we call cradle to grave. It is capturing CO2, transporting it, and then storing it. We have decarbonization efforts and some efforts in hydrogen, and you will hear about that later in the program. And then we also have some projects going on the critical mineral space. So just like most energy groups around the world, we are looking at all aspects of energy transition while providing what we consider sufficient energy for the world. So at least from our perspective, what we want to do is to bring these two significant energy groups together to see what type of synergies we can realize. And so, of course, network, explore, discover, and I think as we meet, new ideas will come up and new initiatives, I think, new partnerships will be forged. So we basically are a landlocked state, whereas you have a state that is right next to a big ocean. We also have a big kind of a ocean in our midst, which currently is endangered, the Big Salt Lake. But anyway, so I think, and one of the motivations for bringing us together also was the football game on Friday or Saturday, when University of Utah, which is not doing that great this year, is meeting University of Houston. So very happy to see you all here, and we would like to continue this conversation. Thank you.
Thank you.